Dear students, welcome back. So today we are going to start a new topic which is understanding quadrilaterals. You know, a quadrilateral is a figure consisting of four sides. But before knowing about these quadrilaterals, first we'll discuss something about the polygons, that is having any number of sides. So before going to quadrilaterals, we'll first study something about polygons. Now, first of all, we have to understand what are open curves and closed curves. Open curves and closed curves. Now, open curves are those curves in which the starting line, the starting point and the end point are different. Like if I start from here, say I make these lines and this is the finishing point, then this is an open curve because the starting point and the finishing point are different. Now what are closed curves? Closed curves are those curves in which the starting point and the finishing point or the end point are the same. Like here you can see the starting point and the end points are the same, so they are called the closed curves. Clear? Now in closed curves, I hope it is clear what are open curves and what are closed curves. Now simple closed curves. Simple closed curves are those closed curves in which the curve does not intersect itself at any point. Like if I make like this, so this is a simple closed curve, whereas a complex closed curve is like this. You can see the starting point and the finishing point are the same, but the curve is intersecting itself at this point. So it's a complex closed curve. So these are the difference between simple closed curve and the complex closed curve. Clear? Now about the definition of polygons. A simple closed curve made up of only straight line segments A simple closed curve made up of only straight line segments is called a polygon. It is called a polygon. A simple closed curve made up of only straight line segments is called a polygon. Clear? Now, as a polygon is a closed curve and that too made up of straight lines, so it's very clear that the minimum number of sides that a polygon can have is 3. Means using two straight lines you cannot make a closed curve, so minimum 3 sides is there in a polygon. So a 3-sided polygon three-sided polygon is called a triangle. A three-sided polygon is called a triangle. A four-sided polygon is called a quadrilateral. A five-sided polygon is called a pentagon. A six-sided polygon is called a hexagon. A seven-sided polygon is called a heptagon, or it is called a septagon also. An eight-sided polygon will be an octagon. A nine-sided polygon is called a nonagon, and a 10-sided polygon is called a decagon. A polygon can have more than 10 sides. It can be 15, 20, 25, 30, whatever. So in that case, we call it, say a polygon has 15 sides, we call it a 15gon. Or suppose a polygon has 27 sides, we call it as 27gon. Clear? So these are all our polygons. Now we will study something about the polygons in details. Convex polygon. Convex polygon. Now what are convex polygon? Now you know, in any polygon, these angles are called the interior angles of the polygon. These angles A, B, C, D, E and F, they are called the interior angles of a polygon, and these angles they are called the exterior angles. X, Y, Z, M, N, P, they are called exterior angles. Okay, so these are the interior angles and exterior angles of a polygon. Now in a polygon, if all the interior angles are less than 180 degree, then it is called a convex polygon. So if all the interior angles are less than 180 degrees, then the polygon is called a convex polygon. Is called If all the interior angles are less than 180 degree, then the polygon is called a convex polygon. Clear? The example is there only. You can see all the angles, all the interior angles, they are less than 180. So it is a convex polygon. And then the other one is a concave polygon. Concave polygon, in a polygon, if at least one angle is more than 180, I repeat, in a polygon, if at least one angle is more than 180, then it is called a concave polygon. You can see there is a polygon, say A, B, C, D, E, F, G, H, I and J. Now, how many sides are there? 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. 10 sides are there, so you can say it is a decagon because there are 10 sides. But if you see in this decagon, this angle is more than 180, another angle more than 180, another angle more than 180, fourth angle more than 180, fifth angle more than 180. So you can see there are 5 interior angles which are more than 180 degree. So it is called a concave polygon. If one angle is more than 180, then also it is called a concave polygon, or any number of angle, interior angle, if it is more than 180, then it is called a concave polygon. Although we are interested with convex polygon only in this exercise, but you must know what are concave polygons. So if at least one interior angle is more than 180 degree, then it is called a concave polygon. So I hope it is clear what are convex polygons and what are concave polygons. Clear? Now diagonals of a polygon. Now what are the diagonals of a polygon? If you join any two consecutive vertices of a polygon, then you get a diagonal. Now let me explain. Suppose there is a polygon. Okay. Now more precisely you can see it is a hexagon because there are 6 sides. Now this A, B, C, D, E and F, they are called the vertices of this polygon or this hexagon. They are called the vertices of the hexagon. A, B, B, C, C, D, D, E, F and F, they are the sides of the hexagon. Now A, B will be the consecutive vertices, B, C will be the consecutive vertices, C, D will be the consecutive vertices, so on, D, E, E, F and F, they are consecutive vertices. But now I said if you join any two non-consecutive vertices, then only you will get a diagonal. Now see, I'll use a different color for the diagonals. A, B consecutive, but A and C will be non-consecutive. So if you join, so AC is a diagonal. Similarly, AD is again non-consecutive, another diagonal. AE is non-consecutive, so another diagonal. But AF is again consecutive, so it will not give you the diagonal. Similarly, BC is consecutive, but BD non-consecutive, so you will get a diagonal. BE non-consecutive, so you get another diagonal, and BF again non-consecutive, so you will get another diagonal. BA, they are consecutive. Now CD consecutive, but CE they are not non-consecutive, so you will get a diagonal. CF non-consecutive, you will get a diagonal. CA non-consecutive, but we have already drawn the diagonal AC. Now DE they are consecutive, but DF they are non-consecutive, so you will get a diagonal. DA we have already made, DB we have already made. So you can see we have made all the diagonals of the given hexagon. So the definition of diagonals of a polygon will be the line obtained by joining any two non-consecutive vertices of a polygon gives the diagonal of the polygon. So the line obtained by joining any two non-consecutive vertices of a polygon gives the diagonal of that polygon. Clear? Now one thing, this is a triangle. Definitely a triangle is a polygon. AB consecutive, AC is also consecutive, BC is consecutive. So in a triangle, no two vertices are non-consecutive. So the number of diagonals in this case will be 0. No diagonals are there. In a triangle, we don't have any diagonals. Okay, now this is a quadrilateral, any quadrilateral ABCD. Now you see AB is consecutive, but AC is non-consecutive, so AC is a diagonal. Again AD is consecutive, BC is consecutive, but BD is non-consecutive. Now another diagonal, and that's all. So you can see how many diagonals are there? There are two diagonals. Two diagonals. We have two diagonals over there. Now I'll draw a pentagon. You can see this is a pentagon. How many sides are there? 5 sides. A, B, C, D and E. And now we will draw the diagonals of the pentagon. AB consecutive, but AC non-consecutive. So first diagonal, AD non-consecutive, so another diagonal, but AE is again consecutive. BC consecutive, but BD non-consecutive, BE non-consecutive, B again consecutive. CD consecutive, but CE non-consecutive. So you can see how many diagonals are there? There are 5 diagonals. In a pentagon, there will be 5 diagonals. 5 diagonals are there. Clear? And now, if in a hexagon you count the number of diagonals, you see 1, 2, 3, then 4, 5, 6, then 7, 8, then 9. So how many diagonals are there? 9 diagonals are there. Okay, there are 9 diagonals. Okay, in a hexagon there are 9 diagonals. Now you see there is a formula for the number of diagonals in any polygon. Number of diagonals in an n-sided polygon is equal to n into n minus 3 upon 2. Using this formula, you can directly find out the number of diagonals in a polygon. Number of diagonals in an n-sided polygon is given by n into n minus 3 upon 2. Now, we will verify this formula. If we talk about a triangle, how many sides are there? 3. So, if you put 3 over here, 3 minus 3 becomes 0 and everything is 0. So, no diagonals are there. Now, in a quadrilateral, there are 4 sides. So, in place of n, if you write down 4, so 4 minus 3 will be 1. 4 upon 2 will be 2. So, you can see there are 2 diagonals. Now, if we talk about a pentagon, how many sides are there? 5 sides are there. So, in place of n, if you write down 5, so 5 minus 3 is 2. This 2 is cancelled with this 2. Only n is equal to 5. So, you see 5 diagonals are there. Now, if we talk about the hexagon, how many sides are there? 6 sides are there. So if you put 6 in this formula, 6 minus 3 is 3, 6 into 3 is 18, upon 2 is 9. You can see there are 9 diagonals. So we have verified the formula for these 4 figures. Actually, this formula is true for all the figures. So now it is very clear to you what are the diagonals of a polygon. Okay. A very interesting fact about the diagonal and the convex and concave polygon is like this. In a convex polygon, all the diagonals are inside the polygon. In a convex polygon, all the diagonals are inside the polygon. In a concave polygon, at least one diagonal is outside the polygon. So it's a very interesting thing. In a convex polygon, all the diagonals are inside the polygon, and in a concave polygon, at least one diagonal is outside the polygon. Now see, this is a convex polygon because you know all the interior angles are less than 180 degrees. So it is a convex polygon, or it's a pentagon actually. And this is a concave polygon because one angle is more than, one interior angle is more than 180 degree. And this concave polygon, actually it's a quadrilateral because it has 4 sides, but one angle is more than 180, so it is a concave polygon. Now I'll draw all the diagonals of these two polygons. In this, AC is one of the diagonals, We have already done it. AD is the other diagonal, BD is the third diagonal, CE is the fourth diagonal, and one more is left, and BE is the fifth diagonal. So there are 5 diagonals, and you can easily see all the diagonals, they lie inside the polygon. Now here you see, I am going to draw all the diagonals of this figure. AB consecutive, AC non-consecutive, so this is one diagonal, and AD again consecutive. Then BC consecutive, but BD non-consecutive, so I'll make this is the diagonal according to the definition, and then CD consecutive, CA consecutive, and all. So you can see how many diagonals are there? 2 diagonals. But the diagonal AC is inside the polygon, whereas BD is outside the polygon. So always remember, in a polygon, in a convex polygon, all the diagonals, they lie inside the polygon, whereas in a concave polygon, at least one diagonal, it lies outside the polygon. Clear? Angle sum property of a triangle. All of you know that the angle sum property of a triangle says the sum of all the angles of a triangle is always 180. So it's very easy to prove also. Suppose there is a triangle, say A, B, C. A, B, C is a triangle. Okay. Now this angle A is X, angle B is Y, angle C is Z. Now you draw a line passing through B and parallel to AC. You draw a line passing through B and parallel to AC. All of you know, if this angle is X, then this angle will also be X by, as they are alternate angles. Similarly, if this angle is Z, then this angle will also be Z, as they are alternate angles. And now, as it is a straight line, and straight angle is always 180, so you can say that X plus Y plus Z is equal to 180. That means angle A plus angle B plus angle C is equal to 180. This is the angle sum property of a triangle. Okay. Now, angle sum property of a quadrilateral. Angle sum property of a quadrilateral. Now, suppose there is a quadrilateral like this, ABCD. Now, if we draw one of the diagonals, say AC, we have drawn the diagonal AC. Now, you can see that quadrilateral is divided into 2 triangles. Now, suppose this angle is X, this is Y, this is Z, this is P, this is M, and this is N. Now, in triangle ABC, X plus N plus M is equal to 180. That is angle sum property in a triangle. And in triangle ADC, Y plus Z plus P is equal to 180. Once again, angle sum property of a triangle. Now, if we add these 2 equations, means X plus Y plus N plus Z plus M plus P is equal to 180 plus 180 is 360. Now, if you see, X plus Y is nothing but angle A. So, X plus Y is angle A here. X plus Y. Then this N is nothing but angle B, and then M plus P is angle C and Z is angle D. Now you can see we have found that sum of four angles of a quadrilateral A plus B plus C plus D is equal to 360. Clear? That is called the angle sum property of a quadrilateral. Sum of all the four angles of a quadrilateral is always 360. Clear? Now in the same way, we can find the sum of all the interior angles of a polygon of n side, and the formula for that is sum of all the interior angles of n-sided polygon is equal to n minus 2 into 180. N minus, the formula is sum of all the interior angles of n-sided polygon will be n minus 2 into 180. Now you can easily see, if we are considering about the triangle, you put n is equal to 3 here. 3 minus 2 is 1, 1 into 180 is 180. So you can see the sum of all the interior angles of a triangle will be 180. Now, if we consider a quadrilateral, that means in place of n we have to write 4. 4 minus 2 will be 2. 2 into 180 is 360. We have already proved that sum of all the four angles of a quadrilateral is 360. Now, there is one more formula. Sum of all the exterior angles of a polygon of n sides is equal to 360 degree. Now you see, it is very interesting that the sum of all the exterior angles of a polygon of n sides is always 360, irrespective of how many sides are there. The sum will always be 360. Clear? Now you see, I'll give you an example of that. This is a pentagon. A, B, C, D, E is a pentagon. Now, suppose this angle is small a, this is small b, this small c, this small d, and this is small a. So, A plus B plus C plus D plus E, that is sum of all the interior angles of a pentagon, we can find from here. In place of n you write down 5. So 5 minus 2 into 180. All of you know that 5 minus 2 is 3. 3 into 180 is 540. So that means sum of all the interior angles of a pentagon is 540. That means A plus B plus C plus D plus E is equal to 540. Now they are all interior angles. Now see, if I extend this line, this is one exterior angle, it becomes 180 minus A. Then this becomes 180 minus B, because they are all linear pairs, you can see. This is 180 minus C. This is 180 minus D. And this is 180 minus E. They are all forming linear pairs. So these are the exterior angles. Now you find sum of all the exterior angles. Sum of all the exterior angles is equal to 180 minus A plus 180 minus B plus 180 minus C plus 180 minus D plus 180 minus E. Now see, 180 plus 180 plus 180 plus 180 plus 180. How many times? 5 times. 180 into 5, 900. So 900 and then you take minus sign common, so within brackets you will have a plus b plus c plus d plus e. Now a plus b plus c plus d plus e we have already found, it is 540, and 900 minus 540 is nothing but 360. So you can see in any quadrilateral, in any polygon, the sum of all the exterior angles will be 360. Sum of all the interior angles will be n minus 2 into 180, and sum of all the exterior angles will be 360. Clear? Now we'll discuss something about regular and irregular polygons. Now, what are regular polygons? In a polygon, if all the sides are equal to each other and all the angles are equal to each other, then it is called a regular polygon. I repeat, if all the sides are equal to each other and all the angles are equal to each other, then it is called a regular polygon. For example, three-sided regular polygon. Three-sided regular polygon is actually equilateral triangle. It is equilateral triangle because you see in an equilateral triangle, these all three sides are equal and all the angles are equal to 60 degrees. So it is a regular. It's a regular polygon. Now four-sided regular polygon will be a square, because in a square you see all the four sides are equal and all the four angles are also equal. So a square is a four-sided regular polygon. Then we can have five-sided, six-sided, seven-sided, so on. So this is the definition of a regular polygon. Now, as all the interior angles are equal in a regular polygon, similarly all the exterior angles are also equal. So there is one more formula, each interior angle of a regular polygon of n sides is equal to n minus 2 into 180 upon n. I have already told you that each interior, the sum of all the interior angles of a polygon is n minus 2 into 180. Now if it is a regular polygon, then all the angles are equal. Now in n-sided polygon there will be n angles, and if all angles are equal, then each angle will be equal to n minus 2 into 180 divided by n, because all the angles are equal and there are n angles. Okay. Similarly, each exterior angle of a regular polygon of n sides, I have already told you that the sum of all the exterior angles is 360 degree in a polygon. Now in a regular polygon, all the exterior angles are equal and there will be n exterior angles, so divided by n, it is 360 upon n. Each exterior angle will be 360 upon n. So we can use this formula for various questions. So we will try a few questions now. The first question is find the sum of all the interior angles of a 12-sided polygon. So I told you that the formula for sum of all the interior angles is n minus 2 into 180, where n is the number of sides. So how many sides are there? 12 sided. So it is 12 minus 2 into 180, that is 10 into 180, that is 1800 degree. So you can see sum of all the interior angles of a 12-sided polygon will be 1800 degree. Clear? Now question number 2 is find each interior angle of a regular octagon. Each interior angle of a regular octagon. So I just told you that the formula for the each interior angle of any regular polygon is n minus 2 into 180 divided by n, because there will be n sides, so n angles, all the angles are equal, so divided by n. Now here it is an octagon, and in an octagon how many sides are there? There will be n, there will be 8 sides, so in place of n you should put 8. So 8 minus 2 into 180 upon 8. Clear? Now if you cancel it by 4 like this, now 8 minus 2 will be 6. 135 degree. Each interior angle of a regular octagon is 135 degree. That is your answer. Clear? Now the third question. Find each exterior angle of a regular polygon of 18 sides. So I told you that the formula for each exterior angle of a regular polygon is given by 360 upon n, because you know that in any polygon sum of all the exterior angles is always 360, irrespective of how many sides are there. And in a regular polygon all the exterior angles are equal, and if there are n sides there will be n angles. So to find each exterior angle we should divide it by n. Here n is 18, so 360 upon 18, that is equal to 20 degree is your answer. The answer is 20 degree. Next question. Find the number of sides of a regular polygon if each interior angle is 156 degree. Find the number of sides of a regular polygon if each interior angle is 156. You know that if there are n sides, then the formula for each interior angle is given by n minus 2 into 180 upon n, and now they are saying it is equal to 156. It is given in the question that this sum is equal to 156. You open this bracket and cross multiply this n to that side, so it is 180n minus 180 into 2 is 360 is equal to 156n. So 180n minus 156n, if you bring it to this side, is equal to 360. Shift 360 to that side. 180 minus 156 will be 24. So 24n is equal to 360. So n will be equal to 360 upon 24. Cancel it by 12. 30 upon 2 is 15. So there will be 15 sides in that polygon. So these are few examples based on polygon. So we'll continue with more questions in the next class. So do all the sums given in the assignment as well as the exercises. The PDF has already been sent to you. So try all the questions, practice, because geometry requires more practice. Okay, so see you in the next class.